Perfect. Perfect. Perfect.
Hello everyone, this is chapter 1, lesson 1.5. In today's lesson, we are going to be talking about how to subtract rational numbers. Now remember, rules still stay the same for adding and subtracting numbers. I'm just going to repeat them one more time just so we can be clear. It is same sign. What do? We add. Different signs. What do? We subtract. I think it's very important if you continue to say these words as you do these problems. So even if you're by yourself, just say it in your head. All right. So let's see. Let's start off with a problem. Well, we have 1/5 minus a negative 4/5. What do you guys notice already about this problem? Well, the simple solution from the last video is that this is called, does anybody know? This is called a double negative. Okay, so a double negative, what happens with them? Well, they turn positive. So let's rewrite this problem. We have 1/5 plus 4/5, and that's going to get us 1 whole, or 5, or we'll just say 5 over 5, which actually leads to simplify 1 over 1, which leads to actually just 1 whole. So the answer for this problem is 1. Okay. Now let's try another problem that says subtracting rational numbers. Well, let's take a look at this problem. First thing we need to do is look, we see that this is a mixed number. We have a whole number and a regular fraction. We also see same sign or different sign. It looks like they both are negatives. That means we need to add these together. First thing I want to do though is I want to turn this into an improper fraction. Now if you forgot how to do that, all we need to do is we're going to multiply our denominator by the whole number, and then we are going to add our numerator. So 7 times 4 is 28, and then 28 plus 1 is 29. So that's going to give us 29 over 7. Remember that that is a negative, and then we have subtracted by 5 over 7. Now how do we add and subtract fractions? Remember, the denominator stays the same, so that's 7, and now we just need to add or subtract these. Let's see, are they the same sign? Yes, they are. So what happens if they are the same sign? We need to add. So we have 29 plus 5, that's going to get us 34. Now remember that both of these are negative. I'm going to do it in blue so you can see. Both of those are negative. That means that is a negative 34 over 7. Let's simplify this and turn it into a mixed number. So let's see. How many times does 7 go into 34? Remember, the denominator stays the same. So 7 goes into 34 4 times. Okay. And then what's left over? That's 28, and then we have 34 minus 28, and that's going to give us 6. Remember that this is a negative, so that's negative 4 and 6 over 7. If you want to rewind and rewatch all the steps, please do so you can see how we did that problem. I'm going to do another problem over here. Let's do this practice problems. What do we notice over here? This is a double negative, and that turns into a positive. So now we just need to rewrite our problem. 1/3 plus 1/3 is going to give us, remember, denominators stay the same. Let's add our numerators. That's going to give us 2 over 3. All right, let's try another one. Same as the one above. It looks like we have, this is a negative, this is a negative. So if they are the same sign, we have to add. All right, but the one thing that I do notice is that this is a mixed number, so let's turn it into an improper fraction. So do that. So we multiply our denominator by our whole number. So 3 times 3, that gives us 9. Let's add our numerator. Plus 1 gives us 10. So that's 10 over 3. I'll do that again. So we multiply this, and then we add this. 10 over 3, that's a negative, minus 2 over 3. Denominator stays the same. Remember, same sign, so that means we need to add. So 10 plus 2 gives us 12 over 3. They are negative. And now let's simplify this. How many times does 3 go into 12? I know it goes into there 4 times. All right. And that is a negative 4. All right. That is example. Oh, let's try one more. Check this one out. This one might throw some of us off. So let's see if we can solve this. Now, this is probably, you probably have seen this before. We've done these problems before, but what happens when you have a whole number and then a mixed number? Well, how do we turn a whole number into a fraction? We can put it over 1. All right, so now that we remember that, to turn a whole number into a fraction, we just put it over 1. So now let's add or subtract. Let's see, same sign or different signs? Well, it looks like this is a looks like this is a positive, and then this is a negative. So that means we need to subtract. Now, the other thing I notice is this is a mixed number. Let's turn it into an improper fraction. So let's multiply. 2 times 5 is 10, and then 10 plus 1 gives us 11. So that's 11 over 2. That is negative, and then we have 4 over 1. Remember, to add or subtract fractions, we need to have a common denominator. So our common denominator is 2, so let's just turn this, multiply by 2, multiply by 2, because whatever you do on the bottom, you got to do on top. So let's rewrite our problem. 4 times 2 is 8. 1 times 2 is 2 minus 11 over 2. Now, how do we add or subtract fractions? Remember, denominators stay the same. That's 2. And these are different signs. So if they are different signs, we have to subtract. So 11 minus 8 gives us 3. Do we have more negatives or do we have more positives? Looks like we have more negatives, so that is a negative 3 over 2. All right, that is example number 1. Please make sure to go back and watch all 4 of these examples if you are struggling. In example number 2, we are going to be subtracting decimals, positives and negative decimals. All right, same rules still apply. Same rules still apply. Same sign, add. Different sign, subtract. Well, let's take a look at this problem. Do they have a different sign or same sign? Well, let's see. Is that a positive 2.4 or a negative 2.4? That is a positive 2.4. So it looks like they are different signs. So if they are different signs, we have to subtract. So let's put the bigger number on top. So 5.6 minus, remember, we always have to line up our decimals. All right, we're lining up our decimals. Now let's just subtract. 6 minus 4 gives us 2. 5 minus 2 gives us 3. Let's drop down our decimal, and we have 3.2. Oh, I forgot. Do we have more positives or more negatives? It looks like we have negative 5.6, positive 2.4. Looks like we have more negatives, and that is a negative 3.2. Okay, let's do another example right here. Let's see, same sign or different sign? It looks like they are the same sign. So if they are the same sign, we have to add. All right, so let's do that. We have 3.9 plus, remember to line up your decimals, 2.1. Let's add. 9 plus 1 gives us 10. Carry the 1. 3 plus 1 is 4. 4 plus 2 gives us 6. Remember to drop your decimal. Both of these are negative, so that's going to give us a negative 6.0. Do we need to have that 0.0? No, we can just have negative 6. So the answer is negative 6. Let's try one more. Check this one out. What do we notice here? This is called what? Double negative. What happens with double negatives? Remember, there's nothing between them. No numbers, no letters, no nothing. It's just negative sign, usually a parenthesis, and then a negative sign. So what happens with double negatives? Double negatives turn positive. Good. So now let's rewrite this problem. We have negative 8.8 plus 8.8. Now this is a special problem. We talked about it, I think, in lesson 1.2. Do you guys remember what this is called? This is called a additive inverse. And what's special about adding its inverse? Remember I gave you the example. If I gave you $5 and then I took that $5 back right away, how much money do I still have? 0. So adding its inverse or the reverse is 0. So negative 8.8 plus a positive 8.8 is going to give you a 0. All right, that was example number. In example number 3, we are going to use properties of addition. All that means, remember, we have to follow the rules of PEMDAS. Please excuse my dear Aunt Sally. So we have parentheses, we have exponents, we have multiplication and division. Remember, we do that left to right, right? And then we have addition and subtraction, and we also do that left to right. All right, so we're taking a look at this problem. That means do I have any parentheses? I do. I have this parenthesis right here. And what do I notice about that parenthesis? I have a double negative. So let's solve that first. Remember we talked about a little bit about distribution and rainbow. All right, so if I had to multiply this like that, that's double negatives turn to positives. So let's rewrite our entire problem. So we have plus 6 7/8. Let's drop that down. We have negative 8 1/2. Then we have negative 1 3/8. Okay, so we have this problem here. Now, do we have any more parentheses? Nope. Do we have any exponents? Nope. Do we have any multiplication or division? Nope. We got addition and subtraction. But then we have addition and subtraction. How do we do our addition and subtraction? We do it from left to right, just like you read a book. We do it from left to right. So that means we're going to start on this side and then go that way. So the first problem that we can solve is this one right here. Well, here's one thing that I noticed right away. We have different denominators. We have an 8, we have a 2, and we have an 8. So it looks like those two are the same. The only one that's different is this one. So how can we get that one to have a denominator of 8? Well, we're going to need to, multiply some things. What I really want to do is I want to turn these into improper fractions. It just makes it so much easier for me to multiply or add when I have improper fractions. So let's do that right now. 8 times 1 is 8. 8 plus 3 is 11. So we have 11 over 8. Remember, that is a negative. We now have 2 times 8 is 16. 16 plus 1 gives us 17 over 2. Remember, that's also a negative. And now we have 8 times 6, which is 48. And then 48 plus 7 is going to give us 55 over 8. And that is a positive. All right, now that we got that, it looks like I can solve this one just a little bit faster. So how do we get this 2 to have a denominator of 8? Well, what can we multiply by? We can multiply by 4. Whatever you do on the bottom, we can do it on top. So let's multiply by 4. So let's do that. Let's rewrite our problem. We have a negative 11 over 8 and minus, that's also going to be in 8. Let's do 17 times 4, right? 17 times 4. 4 times 7 is 28. Carry the 2. 4 times 1 is 4 plus 2 is 6. So it looks like it's going to be 68 over 8. And then we have plus 55 over 8. All right, so notice all this, we did these in a few steps. All right, we got rid of that double negative. That was step number 1. And then we got the common denominator. That was step 2. And now in step 3, all we did is made sure we had that common denominator. We wrote the problem, and now we're ready to solve. So let's start this off right here. Same signs or different signs? Well, it looks like they're both negatives, right? So that means if they're both the same sign, we need to add. So 68 plus 11 is going to get us what? Let's see, 8 plus 1 is 9. 6 plus 1 is 7. So that's 79 over 8. They're both negative, so that gives us negative 79 over 8. Let's bring this down, plus 55 over 8. So now let's do this next step. Same sign or different sign? Looks like they are different signs, so that means we need to subtract. 79 minus 55, that's 4, that's 2. Do we have more negatives or more positives? It looks like we have more negatives, so that's negative 24 over 8. We can still simplify that. Let's see, how many times does 8 go into 24? That's going to be 3, and a negative divided by a positive is going to give us a negative. So the answer for this question is negative 3. Please rewatch this problem a few times if you are struggling on this, especially during your homework. This was example number 3.
Perfect.